This is the first in a series of lectures that deal with section 2.2 on set operations. And in this particular video, we'll show how to generate new sets from given sets using various set operations. We'll give working definitions of those set operations, and we'll illustrate what they look like using Venn diagrams. So let's start with two sets A and B, and we're going to define these new sets denoted in this way. So we're defining four new kinds of sets generated from A and B as follows. This one is referred to as the union of A and B, and I'm giving a working definition using set builder notation. So you read this as the set of all x in the universe such that x is an element of A or x is an element of B. This one is called the intersection of A and B, and it's exactly the same definition except we change the word or to and that makes an enormous difference. It's the set of all x in the universe such that x is an element of A and an element of B. This one is referred to as the set theoretic difference of A and B. It has nothing to do with arithmetic. It's defined to be the set of all x in the universe such that x is an element of A and x is not an element of B. And this one is referred to as the complement of A. It's the set of x in the universe such that x is not an element of A. And finally, we say that two sets are disjoint provided their intersection is empty. So let's draw some Venn diagrams to see what some of these concepts actually look like. First of all, we'll draw the union. So if we make a universe like this, and this is supposedly A, and everything in this circle is B, then the union would be everything in either of the two circles. So that would illustrate A union B. The intersection would be everything that's common to the two circles. So again, this is A, this is B, and the intersection would be here. So it's much smaller than the union in general. So this illustrates A intersected with B. Okay, now what about the set theoretic difference? If this is A and this is B, then the set theoretic difference is everything that's in A but not in B, and so it would be this region here. That's the set theoretic difference. And what about the complement? If we just draw a single circle for A, the complement is everything in the universe that's not in A. So that would be out here. That's a complement. And now we can also illustrate the idea of two sets being disjoint. Disjoint sets look like this. They have an empty intersection, so that it would illustrate two sets being disjoint, A and B disjoint. And finally, I want to illustrate two sets for which one is a subset of the other. So if A is a subset of B, that would look sort of like this. If this is A, then B would be something like that, if A is a subset of B. Okay, so that illustrates the various concepts that we've studied in this video and in the previous video. In the next video, we'll look at some proofs related to these ideas, some formal proofs.